extra. This one's a little bit of trickery, I should say, due to the fact that we're throwing in a third variable that most kids don't think about, and that is the concept of cost. Situation from the notes: a can shaped like a right cylinder with a volume of 1 cubic foot is made from materials that cost 80 cents per foot. A vertical seam and the top and the bottom are soldered at a cost of 20 cents per liter foot. Find the dimensions of the can that minimizes the cost. Well, again, you're taking this particular piece of sheet metal, you're going to solder it together, and then solder on the top, solder on the bottom. So we want to minimize cost. Cost, of course, is based upon how much surface area you have to cover. So I will begin this problem by looking at surface area, the all too familiar formula of 2 pi r squared plus 2 pi r h. Of course, we need volume to get rid of one of those variables. My volume is 1, so pi r squared h is equal to 1. Do the magic substitution of pulling out h again, cleaning it up, and there's my surface area equation. Now's where the confusion comes. There are two costs associated with this surface area. One is just to make it at 80 cents per foot. So I need to take this equation and I have to apply that it's 80 cents per foot that I'm doing, what I call whole can material. Now once I've constructed the side and once I constructed the top and the bottom, I have to put them together. That's the soldering that needs to be done here. Okay, so I'm going to solder the vertical seam, which is the height of the can. So again, going by the picture, this surface needs to be put together. Think of it as a piece of paper that you're rolling up. You have to put those two ends together. And then I have to solder the top and the bottom circles on. Solder the top, solder the bottom together. Those costs are at 20 cents a piece. Here's the 20 cents for the vertical seam. Here's the 20 cents for the top circle. And of course for that, the bottom circle. Now I'm not using pi r squared because I'm not soldering an area. I am soldering the circumference around this particular part. So here is my cost equation. Now I'm going to clean it up a bit, distribute the 0.8, change that h out of there with what we know h is equal to, and clean this up into that particular value. This is what I'm going to take the derivative of. Not a bad derivative right here, but again, kind of complicated to solve. So I'm going to let my calculator solve this equation equal to 0. I'm going to graph this equation, or if I have a TI-89, I could use the algebra solver, type this in, set it equal to 0, go comma, close parentheses with an x there to make sure the calculator knows I'm solving not for r, in this case x, same concept. Do I have any bounds? Yes, obviously my radius could be at a minimum and it could run on forever. Here are the two zeros I get back based upon my calculator. I have a negative one, because mathematically that makes sense, and I have a positive one. And of course I have that 0 because 0 could be my minimum value. I am then going to create a plus minus chart from that particular one, and this is what I have. Again, it's hard to think of an equation that's going to make sense of that. Notice I have no negative 1 here because it's off the chart. If I use that entire derivative equation and pick a point and plug it in, I make a negative answer. Pick a point, plug it in, I make a positive answer. That is a minimum. If I look at the picture of it on my calculator, there it is. Negative answers, positive answers. Because I'm graphing the derivative, when I go from negative to positive, that has to be a minimum value. So, my minimum radius is 0.497. My height, using the formula that we had for height, pull that back in so you can see that. The height formula is right here. So I'm going to take my radius, which was 0.497, plug it into this equation. I will then get my height. My height turns out to be 1.288. I then have to do my total cost. This is my cost equation right here. And yes, legitimately, I put R in for R here and here. I can put H in for H there, and I put the R there. Good thing we have a calculator. Comes out to be a cost of $5.97. Labeling, you notice I do not have the labeling of feet in these two marks. That is a big no-no on the AP test. Must have units, must have units. Well, I hope these three problems help you. Take a look at them. We are also going to do this in 4.6. We're going to make up some time. Guys, keep working. Keep doing more problems. Please do not just rest. You must keep working, and I will be glad to help anybody who asks for it.